Hello, my name is Mariana Casares. Today I'm going to talk about my BioChemCoRe research project called Contrast of Pocket Volume Fluctuations between A211D, A211T, and wildtype PKA. Protein kinase A, or PKA, is an enzyme whose activity is dependent on cyclic adenosine monophosphate. PKA has several functions in the cell, including regulation of glycogen, sugar, and lipid metabolism. PKA has a cavity that allows cyclic AMP to bind. This type of cavity is what is called a binding pocket. The set of amino acid residues around a binding pocket determines its physicochemical characteristics, and together with its shape and location in a protein, defines its functionality. Proteins are chains of amino acids that need to have a certain order to function properly. However, PKA has been found to have two types of mutations in the binding pocket, where there is a change on the amino acid number 211. On the first mutation, A211T, 309 replaces alanine, and on the second mutation, A211D, an aspartic acid is found instead of alanine. These two mutations lead to two completely different diseases, carnic complex and acrodiocystosis, each one having a contrary effect on the PKA regulation, one reducing it and one increasing it. My project was to measure the volume of the binding pocket on the wild type, which is the non-mutated PKA, as well as on both mutations, in order to answer the question: how do two different mutations in the same residue of PKA result in two distinct diseases with completely different effects on PKA regulation? I used a Python package called PubMe, which fills the pocket with small equidistant spheres to measure the volume, similar to filling a container with water. I then contrasted each value found to find how much the mutations affected the volume of the binding pocket. After doing the PubMe analysis, what I found is that the pocket with the greatest average volume is the wildtype PKA. The mutated A211T is 6% smaller, and A211D is 39% smaller than the wildtype. I then calculated the standard deviation of each mutation and the wildtype in order to know how much each pocket volume changed throughout the frames. The one that changed the most was A211T, changing 27% more than the wildtype. A211D, however, changed 12% less than the wildtype. While analyzing the graphs of the volume, I identified that each pocket has a different behavior. The pocket volume of A211D increases over each frame. A211T's decreases, and the wildtype's increases, but stays mostly the same as how it started. So, how do two different mutations in the same residue of PKA result in two distinct diseases with completely different effects on PKA regulation? Well, all this information gathered from the PubMe analysis showed us that one small change in the protein structure can completely alter the volume of the pocket, making it bigger and smaller, or even more dynamic.